Hello everyone, this video will be a review for the Mastery quiz covering standard G8, all about constructions. So in order to prepare for this quiz, I recommend that you review lessons 1.3, 1.4, 1.5, and 1.6. You can also use the Unit 1 resources, slides 6 through 11, for support and help to review. I recommend that you go back and watch any lesson video highlights from those 4 sections. You can watch this video here, which will review examples from each of those sections, and join class participating in our class review jam, which will take place the day before we take the quiz. Now again, concepts from 1.3, 1.4, 1.5, and 1.6 will show up on your quiz. Let's go ahead and look at some examples from each of those lessons now. Before we get started, I want to remind you about a few basics with constructions. Now, everything in geometry always starts with a point. We can connect 2 points with a line, a segment, or a ray. In most situations for constructions, we will connect 2 points with a segment. Now, the reason we do this is because we will need to control the length of segments to construct most of our figures. We can do this with the compass tool because the compass measures the radius of a circle, and we know that all radii within one circle are congruent to each other. We can create multiple circles that are congruent to each other and multiple radii that are congruent to each other, thus controlling the size of a segment or ensuring that all segments are equal length. In order to achieve this, we will use that compass tool to measure the distance between these 2 points and draw circles around each of these points, creating a circle A and a circle B that are congruent to each other or have equal radii lengths. This chain link, if you will, is where we will usually start most constructions. Please keep in mind what I'm about to show you is the hardest type of question that you will see related to the constructions that you did in each of these 4 sections. The first construction that we'll cover is perpendicular bisectors, are lines that go through the midpoint of a segment, cutting that segment in half, creating a right angle. So what we do is we first start with 2 points, connecting those with a line segment. We'll then link these points together with circles, showing that the radius of circle A is the same as the radius of circle B. We notice 2 intersection points of these circles. Those happen to be the 2 points that will create our perpendicular bisector. Now we have a perpendicular bisector of segment AB. The point that this perpendicular bisector goes through is also considered your midpoint. Looking at another example, we are constructing an equilateral triangle that needs to be inscribed, which means within circle A, and have a vertex at point B. We have multiple ways that we can go ahead and construct an equilateral triangle, one of which is drawing a line from point B to point A going through the circle, looking at what now is the diameter of circle A. From here, we can create 2 additional circles, which will create 3 congruent circles, all having equal or congruent radii. Looking at intersection points, we can connect those to point B and create ourselves an equilateral triangle that has a vertex at point B. Another type of construction that you will need to do would be to construct an angle bisector. An angle bisector is going to be a line that goes through the center of an angle, cutting that angle into 2 congruent parts. We'll start like we do most things with a circle. In this case, we're going to start with a circle around point A. When we do that, we see intersection points along the rays that create the angle. So we have point B and a second point that intersect the circle. We can connect those 2 points with a segment and then link these 2 points together with circles. Every time we do that, our intersection points give us a clue as to what's next. We can see that these two intersection points line up with the vertex, proving that we have an angle bisector going through the midpoint of this smaller segment that we created, proving that we have an angle bisector with this line that we just created going through the vertex of A. And then finally, you will need to construct parallel lines. We've got many different ways that we can tackle this, one of which is to use a parallelogram, because parallelograms have two sets of parallel sides. What we want is a line that goes through point A that needs to be parallel to BC. What I would do in this situation is connect points A and C and B and C so that we can start to see and develop a parallelogram. Parallelograms also have opposite sides that are congruent to each other, so we'll use the circle to force some congruency. So we can use a compass to measure the distance between points C and B, and then move that circle around point A. Doing this shows you the distance that you need from point A to the new point to have a parallel line. We'll do the same thing with the distance between C and A. Put that around point B, again showing you the distance that you need between point B and the new point. The intersection of these two circles show you where that final point of the parallelogram needs to be, and we can draw a line from point A through that point, showing that the line that goes through point A is parallel to line BC. Make sure you take some time to study all of the resources that I recommended, and good luck on your upcoming quiz.